All right, everyone. I think we'll go ahead and get started. Good afternoon. Thank you for joining me for today's Data at Your Desk workshop, Introduction to MATLAB. My name is Dr. Nick Roosh. I am the Research Data Management Librarian here at FSU Libraries. And today we'll be walking through how to get started with MATLAB. Just a couple of housekeeping items before we get going. This workshop is being recorded, and we'll send out the recording plus a copy of the slides at some point after the session, so you will have those to look over. And then if you have any questions during today's session, please feel free to type those in the chat, and we'll get to those kind of as we go along with today's session. So what we will be covering today, I will give an introduction to the MATLAB software. We will talk about the MATLAB interface that you'll see when you open the software and that you would be working in, plus go over some definitions for some different terms, because I feel it's always important to sort of get those out of the way, make sure we all have a common understanding of those different terms and definitions when it comes to the software. Then we'll go into working in MATLAB. So we'll talk about working with variables, importing external data into the software so you can do data analysis with it. We'll do some manipulations with that data. And then we'll finish up by creating some two-dimensional plots. We'll get into how to do some basic plotting within MATLAB. So what we will not have a chance to get into today, I already sort of went over what we will cover. So this workshop is not going to go deeply into introducing coding or programming. We'll talk about how you write out some of the code within MATLAB, but some of the basics behind that we won't have a chance to go over. And then MATLAB also has a lot of optional toolboxes or packages that can be added on to the base software. Each one of those could essentially have its own session in many cases. So we will not have a chance to go over those during today's session. All right, so first I want to start out with a basic introduction for MATLAB and what MATLAB is. So MATLAB stands for Matrix Laboratory. It is a numerical computing environment that is built around the MATLAB programming or scripting language. It was developed in the late 1970s by a mathematics professor by the name of Cleve Moeller from the University of New Mexico. And through several iterations of the software, Moeller's students formed MathWorks, which now offers MATLAB as a commercial product. So that is one thing to note. MATLAB is a proprietary software. We do have it available here at FSU, but just in case you're wanting to use this outside of FSU, outside of your time here, just note that it is a commercial product that does require a license to use. There are currently millions of users of MATLAB worldwide, mainly in the areas of science and engineering. There are applications in certain other areas as well. MATLAB is known for allowing the user to perform matrix manipulations. A lot of the calculations and a lot of what you do is based around matrices. You can plot functions and data. It can be used to implement and develop different types of algorithms. And it also interfaces with programs developed in other language, such as C, C++, Fortran, and Python. And this is initially what it was developed for. It was developed kind of with this interfacing, especially with C++ and Fortran, back when it was first created. Some of the advantages to using the MATLAB software. It has an extensive built-in analysis functionality. There's no need to sort of download multiple packages to use the base software itself and to actually perform analysis and plot graphs. As I said, there are some additional packages you can add on, but just to do like analysis, plotting, a lot of the things that in many softwares you have to download external packages for, in MATLAB you do not. MATLAB also allows you to implement and test algorithms easily. As I said, there's dedicated toolboxes or packages for specific uses. There is extensive help documentation within MATLAB or outside of MATLAB that's been developed both by the MATLAB developers and by the community. So there's a lot of material out there if you need assistance to actually use the software, if you encounter any problems or errors. And it also, and I say easy learning curve here on the slide, relatively speaking. There is still a learning curve, but compared to some other types of data analysis software that are used, this has a much better sort of user-friendly interface that if you're sort of new to coding, new to programming, that you can dive in a little more quickly. It has a lot of that help documentation. It has a lot of different buttons and clicks in there that you can use to perform some of the various functionalities, and we'll explore that a little bit today. So if you are wanting to use MATLAB at FSU, there are a few different places to use the software or to access the software. We have it available in the libraries at Strozier-Dirac and the engineering libraries on the library desktops. Some academic departments have a license to it. I know the College of Engineering has a license to MATLAB, so some can access that through their academic departments. There is also the FSU Virtual Lab, which I'm going to click on that and go to that real quick. And so this is available through FSU ITS. And this allows you access to not just MATLAB, a lot of other different softwares, anywhere that you're at, so whether you're on campus or you're working from home, you're remote, you can access those softwares and use them through this virtual platform. So all this does, if I show how to get into it real quick, is you just sign in and then sign in with your FSU credentials. And then if you get to this screen, you click on apps and you'll see all of the different software that is available through the virtual FSU virtual machine. So you see MATLAB is on here, and they have the 2023A version, which is the what I'll be showing, the desktop version today. All right, let me get back to... All right. So that's a little bit of background on MATLAB, how to access it here at FSU. So during today's workshop, for some of the hands-on demonstration components, I will be using a data set that I've pulled from datausa.io. It goes over commute times or average commute times in a few southern US states compared to the US averages during 2013 to 2019. I have a copy of this data set located in a folder here. If you would like to follow along with this, I'll paste the bit.ly in the chat as well, so that you can access that in case you are following along or using the software, or you would like to have that for later access. This can be downloaded directly to your computer if you're using MATLAB on your computer. You can also upload this to the VLab. I do not have a slide on that. I should probably correct that. But we can also talk about how to get it onto the VLab if that is something that you have questions on later. But this should just be a Microsoft Excel file that you would download. All right, so now we will actually go into the MATLAB software. And so when you first open up MATLAB, this is the interface that you are going to see. So there's a few different parts. We'll go over each of these really briefly. The first of these is the command window. And the command window is where you are going to enter commands, where you're going to enter syntax and code, define functions, and just overall work with your data. This current folder over here, that'll show the different files that you are working with MATLAB, the different what they call paths or file path that you're using in your current session. The workspace, which is often over here on the right-hand side. Here it shows it on the left-hand side. This is where your variables for the various functions that you have are defined. So that's where you're going to find those. And then at the top, you have your toolbars. So you have your toolbars that allow you to perform various tasks within MATLAB, such as assisting with importing data, analyzing code, and then you also have a plots toolbar, which can help when plotting data. And then an apps toolbar, which is where you would access some of those external applications that we talked about earlier, any applications that are downloaded into the software. All right, so a few definitions. When you're talking about MATLAB, MATLAB reads all variables in terms of matrices or arrays, hence the name Matrix Laboratory. So when we're thinking about how we're working with values within MATLAB, we can think about them in terms of arrays, vectors, and scalars. So a scalar is a single value. So if you just have a single number, for instance, and you enter that into MATLAB, MATLAB is going to consider that as a 1-by-1 matrix, one row, one column, just one value. So you could consider that a scalar. We don't often just work with scalars when you get into more complex analyses, but for starting out, we'll have a few just sort of simpler things that we're looking at. So the next definition is a vector. A vector is a collection of numbers in one dimension. The two that we commonly work with in MATLAB are rows and columns. So your row vectors or your column vectors. And then when we put those all together, we have an array or a matrix, and that's a collection of several values of the same type. So you can have a numerical array where you're looking at numerical values. You can have a text array as well, where you're looking at textual values. Those do get used within MATLAB as well. They have a slightly different syntax for doing those, but those are utilized in MATLAB in addition to numerical arrays. So when you're thinking about variables, variables should always have some sort of a name. They should always be assigned, values should always be assigned to a variable with the equals operator. And we'll get into that in a second and sort of demonstrate why you should do that. A variable, as we said, can have an alphabetical, textual, or an integer value. Decimal points can also be assigned to a variable, such as the value of pi, for instance. So when you are writing rows within MATLAB, you're going to write those with these square brackets. That is how you define your vectors within MATLAB for your numerical vectors. When you want to create a row, you have your different values, and you can use either spaces or commas for those. Either one of those will work just fine. I will likely use commas most of the time to sort of differentiate that from our column vectors. Your columns are going to use semicolons. So those are going to go vertically, your rows will go horizontally. You then combine that to create a matrix. So you have your different rows separated by your commas, and then the semicolon between each row, and that'll create your columns. So at this point, I'm going to actually go into MATLAB and sort of demonstrate how to do all of this, since we now have sort of the context. So as we said, this is what your MATLAB is going to look like. So I am going to just type a variable. So I'm going to call this A. I'm going to say A is equal to, and here I am going to just do a scalar. I'm going to just do one value to show you what happens. So let's say A equals to 5, and then we hit enter. So now you'll see that in our command window, that A has been assigned to 5. And then over here in your workspace, you will see that variable A has a value of 5. So if I were to have just typed in, say, 5, for instance, without actually defining that or assigning that to a variable. So if I was to just have typed that in, you see what's going to happen is the software is just going to automatically assign that to this variable ANS or answer. The problem comes is if that happens again, if you don't define something again, say you just put 7, what's going to happen is it will assign that variable again. And then you'll see in your workspace that value was now overridden. And so answer there is now equal to 7. So whenever you have a variable of the same name in the workspace or within MATLAB, it's going to take whatever you use most recently. And that can be an issue if you want to do calculations or any sort of analysis later on. So that's why it's always important to make sure that your values are assigned to a variable with that equals operator in between. So if we want to do a row vector, I'm going to assign that to variable b. We'll say equals. I'm going to do my square brackets. Then I'm going to do 2, 4, 6. This is going to be my row vector. Close the brackets. We'll hit enter. You'll see MATLAB outputs those values, and it assigns the variable over in our workspace. If I want to create my column, C is equal to square brackets, 2, comma, excuse me, that's a semicolon, 2, semicolon, 8, semicolon, 9, close brackets, enter. You'll see that gives us our column. And then if we want to create our matrix, and this will be a 3 by 3 matrix, we'll go 2, 4, 6 for our first row, 8, 3, 1 for our second row, 9, 2, 5 for our third row, and there's no special meaning behind these values. I am just randomly assigning these. So if I hit enter, you'll see it defines that in our workspace, and then you'll see it now defines it as well there in the command window. So we have our 3 rows, and then the columns. It took the first value for each of those columns, 2, 8, 9, 4, 3, 2, and then 6, 1, 5. So that is sort of the basics behind how MATLAB is going to read the different matrices that you would be utilizing within the software. So most of the time when you are using MATLAB, you're going to be using that for data analysis, right? You won't usually just be creating random matrices. So we are going to, now that we've sort of seen the basics, sort of seen how MATLAB utilizes this, we are now going to go into importing some data and seeing how that process works. So in terms of exporting internal data, MATLAB supports many different file formats for importing data. There's a list of those on the MathWorks website for the many hundreds of formats that they support, and I have a link to that at the end of these slides. It'll be sent out to you at some point after the session so that you can see if yours is supported. But I'm going to paste this link again into the chat for those that have joined us since the beginning. We will be importing a data set into MATLAB and using that for some of the demonstrations later on. For importing data, I like to utilize the import data tool within MATLAB. It's a really nice way, really convenient. It allows you to select your output type, select how you want to import that, and a few other options as well, which we'll get into. So if I go back to my MATLAB software, if you go up to the top under your home toolbar, you'll see right here this import data button. You can click on that. All right, and then it's going to bring up your file browser within your computer. And then you just find wherever you have your data set downloaded to, and then click open. All right, let me bring that over. Can everyone see that pop-up window, the import data window? I know sometimes Zoom is a little weird when you come up with new screens. So just let me know in the chat or with a thumbs up if you can see it. If you can't, let me know that as well. All right. Cool. All right, so we have our import data window. You should see that essentially a copy of that spreadsheet from before. It'll have all the same tabs in here, sort of the raw data that we would pull from the site, and then a couple of tabs where the data has been cleaned up a little bit. So I'm going to use this commute summary tab for demonstration purposes for today's session. So you'll see it has our years that we're looking at. So the years in which this data was collected, our 3 states plus our national average that we're looking at as well. So the first thing that I'm going to do is actually up here, you'll see when I scroll over this, this is called the output variable name. So when we import our data into MATLAB, as you remember earlier, we assigned all of our values a variable name within our workspace. This is what MATLAB will assign our data, the variable name that it will assign to it. So whenever we're doing any sort of analyses or any sort of manipulations to this, we have to type this entire name. So I like to change this a little bit to make this a little bit simpler to bring up. This is, you can use whatever name that you want that you can still remember working with your data. I'm just going to shorten this to commute 1319. You do not have to do this. You can use that longer name. Just know that you'll have to do a little bit more typing when you're working within the software. So the next thing that I like to do after editing this output variable name is go to output type. There's a few different ways you can output your data within MATLAB. I'm going to stick with a numeric matrix for today, since we're sort of learning, how to use the matrix abilities of MATLAB. And then once we have that, we go over to import. And there's a few different selections under here. If we just want to import our data, which is what we're going to do here in a second, we would just click import data. We can also generate some scripts, and we'll talk about what scripts are a little bit later. So we'll leave this up and come back to that. But for now, we're just going to click import data. All right, so we see that it imported our variable as a 7x5 matrix. And you'll see if you go to the workspace and highlight that, you can see that our commute 1319 is there. I always like to double check that it was there. If you go to your command window and type in the name of your variable, so commute 1319, and hit enter, you'll see that this comes up. It shows us our data that we imported into MATLAB. Now, sometimes it'll do something like this. If you remember when we were looking at our data, we had our years, which is our 2019, 2018, and then our time in minutes. And these had some different significant figures. Sometimes MATLAB will automatically set those to have the same number of figures, but these are the same numbers. And you'll see that when we actually extract data and work with data later. But you'll see this come up like this. It's probably something in the settings, but it's done this in every version of MATLAB that I've used. So now we have our data. And this is a pretty straightforward data set. We can see most of the values here. But many of the data sets that you might use are going to be, much larger data sets than this that might have hundreds and hundreds of values in there. And sometimes you want to look at a particular section of this. You want to look at particular values or particular sections, or slices is the term that you'll hear within MATLAB. And you might want to look at those particular slices and do further analysis on those. So now we're going to take a look at how to look at those different slices of data within your data set. So the first we're going to do is selecting one element or one value. So this is more to demonstrate kind of how the syntax actually looks. But we will go into a little bit more how we pull out larger sections. So I'm going to pull out one value. We are going to call that E. So what I'm going to do here is we're going to use E, and then you're going to want to type the variable name. So this is essentially going to tell MATLAB where you want that data to be pulled from. So we want to pull it from our commute 1319. And then in parentheses, we're going to use that to tell MATLAB where we want to pull from, what exactly we want it to pull. And here, let's say we want the value from row 3. So this third row here, that's in the fourth column. So if we have our row 3, column 4, let's say we want to pull that out. So we type our commute 1319. We are going to type 3 for row and then 4 for column. So this is the format you're going to use. I'm going to say E or whatever your name you're calling this is equal to the variable or the data you're pulling from. And then in your regular parentheses, your row and your column. So if we hit enter, you'll see that this has now assigned E is equal to this 23.7699, which you'll see is this. It did round this here. So it has now extracted that value and has now assigned that to our new variable. So that's one value. Let's say we want to pull a whole row or a whole column. To do that, we start out the same, type our variable name. And so now let's say we want to pull all of, the row values from column 2. So if we want to return all of the row values from comma 2, for that we are going to use this colon. So not the semicolon, because that's for something else, but we'll use the colon, comma 2. And you'll see what this has done is this has gone to our column 2, and it has pulled out all of these rows. So this is essentially means all. In this case, we'll see in a second, we can define those parameters, but since we didn't define, it's just pulling all of them, all of the row values in our entire set of data from column 2. So now let's do the opposite. So now let's pull from our commute 13, 19, all of the column values. So remember our second values are column from row 4. So our fourth row is our 2016 data. And you'll see we've now been able to pull that. All right. And then the last thing we can do before we get into doing some plotting with this data is now we can pull kind of bigger slices. So let's say we want to pull from rows 2 through 4. So we want to pull all of the different columns from rows 2 to 4. So instead of having nothing in between that colon, we can now actually define those parameters. So what this is going to do is look through from rows 2 to row 4. It's going to pull out all of those column values. So I forgot to put my 13 to 19. So this is actually a good example of what happens when you encounter an error within MATLAB. So if, say, you type a function, looking for a variable that doesn't exist, MATLAB will come up and tell you that it cannot find that. So that is what this unrecognized function or variable means. So if you get a red error, MATLAB will stop. It won't be able to calculate that. And it will usually tell you what the error is or give you a way to help you figure out what that is. So I am still going to use H because it didn't actually define that. So let's do that H data 13 to 19. And this will also come up a lot if you misspell something. Obviously, MATLAB is spelling sensitive, so if you miss a letter or something, it will also give you that error. Oh, what happened now? Oh, now I said commute data. All righty, there we go. So as you can see, everyone makes mistakes or things happen when you're using these softwares. So now we have pulled our rows 2 through 4 with all of the data there. So now let's return some columns. So say we want columns 3 to 5. So we are going to pull all of those values from columns 3 to 5. So it's pulled all of the different rows from those. So now we have taken that particular slice. So now you've seen a little bit about importing the data, how you would pull different slices out of that. This can be very useful when you have larger data sets and you are looking to analyze specific parts of them, perform functions. Pulling these slices out can be very, very useful. All right, so I am going to go back to the slides. So you'll see I have some of these examples on the slide, so you can go back and look at those later. All right. So at this point, we're going to go into plotting. I will pause briefly to see if there are any questions on any of the things I've talked about so far. If there are, you can put those in the chat. Otherwise, we'll continue on to plotting this data. All right. And we can also come back to these at the end as well, if need be. All right. So now we're going to take a look at plotting or doing data visualization within MATLAB. Before we kind of go into line plots as our example, I will mention there are many different types of plots that you can do within MATLAB. And some of them are more appropriate at different times than others, depending on what type of data that you are looking at, how you're attempting to present your data. So there's many different ways to do this. And there's different functions for each of these different types of plots. But sort of for the sake of time, we're just going to kind of go into how you would plot data using a line plot, just sort of the classic like first example. Line plots within MATLAB or in general will allow us to compare sets of data or track changes over time. Within MATLAB, you can do either two-dimensional line plots or three-dimensional line plots as well if your data is set up for that. You can plot expressions or functions over specific intervals or plot using either linear or log scales. So if we go back to our MATLAB, we are going to work with the data that we already have, the commute data that we had earlier, and we're going to do some plotting. So before we do that, you'll notice that the command window has gotten a little busy. There is a lot here. You can actually go in and clear out your command window, make that a little bit cleaner. To do that, you can use this CLC command. So if you type CLC, that will clear your command window. But notice that your workspace is still there. So all of those variables that you defined earlier are still within the workspace. So those aren't gone. To get rid of those, it is a different function called clear. So that will allow you to clear out your workspace, and you can either clear out a specific variable by typing the variable name, or you can clear out everything by just saying all. We are not going to clear out anything for right now, but you can do that if your workspace is also getting really long. So I'm going to bring our commute data back into the command window so that we can see it. So we'll type commute 1319. And we are going to do a two-dimensional line plot. So within our two-dimensional line plot, we're going to have our x-axis and our y-axis. And our x-axis is going to be the years. So each of our years from 2013 to 2019, or backwards from 2019 to 2013. And then on our y-axis, we're going to have our times, our different states that have their average commute times. So to plot these, we need to define what these are, define what our x and our different y's are. So we're going to go ahead and do that first before we plot. So I'm first going to define x We only have to define one x because we're just looking at years. So we'll say x is equal to commute 1319. All right, so here we are looking at all of the row values from column 1, because that is our years. And then I am going to type this semicolon at the end of our function. So when we type that at the end of our function, what that does is it suppresses the output in the command window. So you'll see that over in our workspace, it has defined X, it has all of our years, but in our command window, it didn't output all of that. This can save a lot of processing time if you are doing a lot of calculations or you are outputting a lot of data. This can save, compute time and process time within the software if you're wanting to do a bunch of things at once. It also helps keep things a little cleaner as well. So now we're going to define our y's, and this is going to be each of our other 4 columns where we have our commute data from our various states. So I'm going to call these y1, y2, etc. So y1, you say commute 1319, pulling all the row values from column 2, suppress that with our semicolon, and then we're going to do the same thing for our other columns as well. We're going to end up with 4 of these. So semicolon, and then y4. We need a semicolon for that instead of our colon. This is what happens when you attempt to type too fast sometimes. All right, and then you should always check in your workspace to make sure those have been defined, and you see that each of our y's has been defined and our x. All right, so now we have defined all of our variables. Now we want to plot. Here in this case, we're going to want to plot 4 lines, right? So we had 3 states, we had our average US time, so we have 4 sets of data points that we want to plot on the same graph. So when you want to plot sets of data on the same graph, there is a command called hold on and hold off to plot multiple lines on the same graph. So when you want to do this, you will first start your sequence by typing hold on. So this puts a hold, that, and what this will actually do now is it actually will bring up a pop-up box with a figure. So you should see another pop-up box in the middle right now with a, it says figure 1. If you cannot see that, let me know. There's nothing there yet because we haven't told it to plot anything yet. But MATLAB knows with this hold on command that we are getting ready to plot something. So it automatically creates this plotting screen for us. So I'm going to minimize this for the moment. And now we are going to plot. To make a 2-dimensional line graph, the function that you are going to use is plot. Not sure why they decided that this particular one got the plot function and everything else got, a different function, but it is what it is. So for this, we are going to type plot and then x comma y1. We want plot, and x is going to be in every one of these because we are plotting each of our y's against our x. Now plot x, y2, plot x, y3, and then plot x, y4. And then once you have written out all of the lines, these sets of data that you want to plot on your graph, you can then type the hold off command. And so this essentially removes the hold. If you try and plot anything after this, it's going to do like a brand new plot. So this essentially ensures that you're not trying to override your same plot and do a different plot every single time. It will plot all of these on the same graph. So now if we bring up our figure 1, all right, I'm just going to show the figure 1 because Zoom is showing me that it is on a different screen. So let's do that. So you'll see this figure 1 is the plot that we have created. So this has all of our different data points, all of our lines. It has our x-axis for our year, our y-axis for our minutes. Of course, as you have to do whenever you're doing any graph within any software, now you'll need to label it and make sure that there's context for what you're looking at. So here within MATLAB, a lot of the tools to do that are already here within this plotting window. If you want to insert an X label, a Y label, or a title, it's already here. So if I say X label, you'll see there is a white box that comes up down at the bottom. It's a little hard to see, but I'm going to type year, and then we'll go insert Y label. And here we'll say time, and this is in minutes. And then I'm going to insert a title here as well. Average commute times from 2013 to 2019. All right. And then one other thing that we can do here, which is nice, you used to not be able to do this directly in the plotting window, but now you can in newer versions of the software. We can add a legend. And so what this legend will do, and I'm going to just drag this. I just clicked and dragged this to a different point so we can see the data better. This will essentially let us label our lines, right? So that if we look at this plot, if we were to actually publish this plot or use this, we would know which of our data is being referred to. And to do that, you want to make sure you have all of your data set, your documentation. You can look back at your original data to find this information. I am not sure why, but anyway. All right, so I am going to cheat a little bit. So I have this written down for what each of these stands for, but you can go back to your original data set as well to compare. All right, and I'm just going to say US average. All right, so you'll create a legend, and now you have your plot. And you can save this plot. You could print this. if you like, you can do other things to this plot as well if you want to use this for a report or presentation, etc. You can do that as well. So that's our plot. All right. So I'm going to get back into the regular MATLAB. And within here, it has given me a bunch of warnings for clicking too many times within the plotting software. So this is also a good demonstration. We saw the error messages earlier that are in red. You will also sometimes see these warning messages within MATLAB, which usually are this really bright orange color. These will not necessarily stop you from running code or performing a particular function within MATLAB, but it is telling you that you attempted to do something that it did not like. And this all had to do with when I was clicking around in the plotting window. If I click one too many times, it will say that I am doing that essentially. So you may see these as well. Just take these as sort of a warning to make sure that everything is going right, but it will not stop you from executing anything. The red error messages will. All right. So if I go back to our presentation, have a few minutes left, we'll talk about scripts in that. I do have some examples, some demonstrations of some of the things I just talked about in the slides, so you can feel free to take a look at those. All right, so the last thing that I'll sort of kind of introduce in this session is scripts. And scripts can be really beneficial if you are running the same type of analysis multiple different times, or if you're doing a lot of analysis that you are attempting to do in a similar way. So if you're using this to, say, look at experimental data or data that you've collected. So scripts are essentially sequential lines of MATLAB commands. They allow for several different commands to be run at once. So you can do what's called running a script, and it'll run all of the commands that are within that script. Scripts are essentially text files. Within MATLAB, they are saved with a .m extension. You can work on these in a text editor of some sort outside of MATLAB and then paste them into MATLAB as well. And these are also beneficial if you have particular things that you're doing with your analyses. You want to add hints for either refreshing your own memory later if you come back to this analysis, or if somebody else is looking at this analysis, it can help you sort of remember kind of what you're doing in each part of your calculations. So when we're going to go back to MATLAB for this. All right, and I am going to clear out our command window. All right, so if you want to generate a new script, if you're on that Home tab, you can click New Script. And you'll see what this does is it opens up a text editor essentially within MATLAB. So it opens up this editor window. And then it also opens a few new tabs at the top of MATLAB. So you'll notice we didn't see these before. Probably the most important one is this editor tab. This allows you to kind of click and do some edits to your scripts. You can also type these out. And this is also where you can run your scripts as well. There is a publish tab, which essentially has some text edits that you can do, bold, italics, etc. It's where you can save your script as that .m file. And then there's some more edits you can do on this view tab, but I'll keep it on the editor tab for now. So essentially what I would like to show for this is essentially from importing the data to plotting it. So all those things that we just did throughout the session, we could automate those. So I am actually going to go in and I'm actually going to clear out our entire workspace. So cleared out our workspace. So what I am now going to do is if we go back to our input data. So if we go back to where we were looking at our data earlier, you'll see this was the data set that we brought in. All right, let's make sure it loads. We outputted that as a numeric matrix. We'll keep that. So now if we go over to import selection, as I mentioned earlier, there are some options for script. So what this is going to do is it's going to generate a script that we can run to import this data. And this can be used in conjunction with all of those other types of analyses that we did. So if we say generate script, and now go back to MATLAB. So now you'll see now it's generated a script for importing this data. So this can be beneficial if you are using the same type of data set. If you're pulling data set from a similar area, if you're similar variables, you can use something like this. And MATLAB will do this for most data sets that you have. So I am going to now go in here and it'll import this. But now I actually want to do some analysis on this data. So I am going to first make some comments. So you'll notice within this script, I'll back up for a second. You'll notice in this script that there are some text information that is denoted by parentheses, and there are some function. So this sort of percentage points or green information here, these are what are called comments. And this is essentially where you would add information on kind of what you're performing, what you're doing, any other helpful information. MATLAB will not run these. It will not attempt to run your comments. So you want to make sure if you have any comments or things that it should run within your script that you denote it with these this percentage here, which you can either type into the editor or there's a little percentage button up here. The things that are not percentage, so here, things that are in black and then sort of in this purplish color, these are our functions and these are what will actually run within MATLAB. So what I am going to do here is I am going to, we'll import our data. I then want it to define my X and Y variables. And so I going to do this. And so we'll say commute 1319. And then we're going to do all of our y's. And of course, I said you wouldn't have to type all of this out. But since this is the first time I am doing this script, I will type it out. If you were to do something similar after the first time, you would already have all of these calculations, so you would not have to do this again. You would just take this script and replace it with, replace anything that you might be doing different in that particular calculation. All right, so we have defined that. And then the other thing that we wanted to do, and I'll click this percentage up here, plot on one graph, since that is what we did this last time. And now we still use the same functions that we did before. We have our hold on. So I did not want to do that. All right. And so that is our script. So assuming we have no errors in this, if we run this, we should be able to go all the way from importing the data to defining our variables and to plotting all 4 of those data points on one graph. And so let's click run. And it's wanting me to save my script. So we'll just say test script. We'll say it's the 26th. So let's save this. And so you'll see it defined, imported our data, defined all of our variables. And then within this figure 1, it plotted our data. And so this looks exactly the same as we saw earlier. So again, scripts can be really beneficial if you have lots of data. You're doing similar calculations. You can just save your script, and after the first time you run it, you can reload this whenever you're in MATLAB, just replace anything that you might be doing differently, or if you're doing the same calculations with a different file, just sort of replace that file name, etc. And then you should be good to go. All right. And so that is the information that I wanted to talk about today. There was a lot of information that was there. I have put up some further resources here on the slides, which will be sent out later. So you can use these if you want to know more about importing and exporting data, list of all the different commands. Then there are some other tutorials as well on LinkedIn Learning, Stack Overflow, YouTube channel for MATLAB. And then if you have any questions after the session, and I see there is a question in the chat, I'll get to that in just a second. If you have any questions after today, please feel free to reach out. Feel free to send me an email, and I would be happy to assist you. And so in the chat, we talk about FSU Virtual Lab version for demo only. Can it be created? I don't believe it can be integrated with like Microsoft Cloud products. I'm not sure about Python since it's within the FSU Virtual Lab environment. I don't think it can be, say, integrated outside of that environment. With other FSU products, I'm not 100% sure. That would be a question I would have to ask ITS. All right. Well, if there are no other questions, thank you all very much for coming, for sticking this out. I hope you have a wonderful rest of your day.